Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Walker Grant Middle School, and we're gonna work through this super simple exit ticket for ourselves, and we want to make sure that we can comprehend and understand those ideas that we have for probability. Again, you're always just saying that the probability of an event is that count of the event in the numerator, and the denominator, it's the total possible count. So let's see for this first problem what we have. Again, it gives you the following number tiles are put into a box, and so again, these are just little tiles or little cards that have a number on them. So for the first one, it says you randomly choose one of those tiles without replacing the first tile. So right away, I can note that this is dependent. We could say, why is that dependent? We know it's dependent because it says without replacing with. Let me move this up a little bit. Without replacing. Alright, so it says, without replacing that first tile, you randomly choose a second tile. What is the probability of choosing two even numbers? So again, some people were wondering if you were taking those two out at the same time. Again, it does happen at the same time, but you want to do one event first and then after. Again, it has that keyword after. After means that that denominator is going to change. So let's see here. Let me zoom out. Alright, so first thing we're going to have, how many total tiles are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 total tiles. And so how many of which are even? So we're saying, what is, let me actually get a different color here. Let's try this one out. All right, how many of which are even? Meaning, is it divisible by 2? So I'm going to find the probability of an even number. So how many even numbers are there? Well, there's 1, 2, and 3. So that means this. I'm going to have 3 even numbers, out of the 9 total tiles. So I have 3 over 9. Again, I can simplify that like this. Again, I divide by 3 over 3. So this is equal to 1/3. So that's going to be our first probability. So now, let's say you take one of those tiles out. Again, since you're not replacing it, you say we take 1 out. How many are left? There's 8. So right away I can say, all right, probability of an even after, take an even out. Again, it changes not only the denominator, so right away we say, all right, this is going to be 8, because there's only 8 tiles left. How many even are there? So if we took 1 away from 3, there would only be 2 even tiles left. Again, make sure if you need to, you can cross them out. You can actually draw little numbers on a piece of paper to kind of visualize that for yourself. Again, we can simplify this fraction. It's going to be 1/4. So then it says, all right, let's multiply these together. So probability of, let me scroll this up. So it's going to be that probability of an even. And again, make sure you guys are seeing this is one event, this is one event, and then as soon as you see that and, it's 2 events at the same time. So that's why we find the 2 separate ones, and then we multiply them together. So I have my fractions set up. So I have this 1/3, and let me box that in. And that 1/3, and I have this 1/4 that I'm going to multiply together to get my values. So again, just like the warm-up, it's 1 times 1 equals 1. Again, multiplying those numerators together. And then 3 times 4, we multiply the denominators together, is going to be 12. For this one, you can just leave it as a fraction to keep it simple. You can make sure if you're having any misunderstandings or anything like that, be able to write it out for yourself. If you can count and if you can multiply, again, those are 3rd grade abilities, then you can do probability. Alright, so now let's erase this real quick, and I will read, in the meantime, I'll read that second one. Again, so you're just using the same tiles for the second part, but it says you randomly pick one of those tiles, you will replace the first tile, then you pick a second tile. What is the probability of picking a number less than 9 and choosing a number greater than 7? So again, we'll find those two events separately, and then we will multiply them together. Okay, so let's see. Again, since it says, where does it say? It says you replace the first tile, so we know that's going to be, these events are now independent, meaning you put it back, okay? So you're going to not be changing that second denominator. So it says independent. Always want to make sure I'm careful on that. Independent. Okay. Always looks weird. Always double checking. So, again, we still have that 9 total tiles. So let's find out. Maybe you can say this. Let me draw the sample space. So I'm going to say sample space, or maybe let's do this. Let's say how many of which are less than 9. I'm going to list numbers less than 9. So let's say numbers less than, meaning smaller than 9. So what numbers are those? So we're going to have, let's see, we have a 1, we have 7, we have a 2, an 8, a 4, and a 5. Again, I'm just listing those values as we know that those are all less than 9. Since we're saying strictly less than, we would not include 9, so be very careful on the wording for that. Alright, so again, they're saying these are the numbers less than 9. So how many is that? Well, we have 1, 2, 3, 4, 5, 6. So we would write it like this. Probability of picking a number, again, I just leave it as x, less than, a symbol less than 9. That's going to be that fraction like this. Again, we have 9 total tiles, and then we have 6 of those tiles are less than 9. Again, it was the number of tiles that are less than 9 over the total number of tiles. Again, we can simplify this fraction by dividing by 3 over 3 as the greatest common factor. So we have 2 over 3 as our simplest form. So now we took a tile out, but how we put it back. So now I can say this. I'm looking for numbers greater than. So now we have numbers greater than 7. There it is. Let's see, which numbers are greater than 7? So we have a 9, a 15, 9, and 8. Someone had a pretty good question. Since those are their own tile, we would still count it. If it was, anything else, you'd have to just read it carefully. But since it is its own tile, we would include it. So now let's see. All right, how many tiles is that? We have the probability of picking a number that is greater than 7. We still have 9 total tiles, so that's our denominator. We have 1, 2, 3, 4 tiles, or 4 numbers that are greater than 7. Since there's no common factor between 4 and 9, we cannot reduce it, So we can keep that as the two fractions that we're multiplying. So we're going to say the probability at the very, very end. Scroll up for one last part. Probability of picking a number less than 9 and a number greater than 7. Again, be able to know what those symbols are saying. So we have those two fractions. So we said, all right, one of them is going to be the 2/3, and the other one is 4/9. Be able to multiply those numerators together. So 2 times 4 equals 8, and 3 times 9 equals 27. Since there's no common factor between 8 and 27, we know that this is the simplest form. We could also change it to a decimal by dividing the numerator by the denominator. Again, you would get 0.296. Since we round to that nearest hundredth, we would say it's about 0.30, which is equal to 30%.